So we're going to cover adding and subtracting rational expressions that have what I would call being alike, like denominators. So this will be part one. And of course, we need to factor first. So these are alike. And what they have is x plus 6 and x minus 3 for the factor. So that's what the denominator is. So, and then the directions say to add, and so we're saying x plus 6, which we know can't be combined. They're not like terms, so we'll just write them as x plus 6. And when you write it over that common denominator, you have x plus 6 and x minus 3. Well, when we reduce fractions, like if I had the fraction of 2 over 6, and I want to reduce this fraction, in my brain, what I need to be thinking about is that with the 2 on top, the bottom can be represented as 2 times 3. So I'm thinking in my mind, what do the top and the bottom have in common with each other that I can pull out of there, that I can divide out of there? And so they have common factors of 2. So basically we say divide both the top and the bottom by 2. And what we have left is 1 over 3. That's how we would reduce this to 1/3, because we have an invisible 1 left on top and the 3 left on the bottom. So the same kind of idea is happening here, where we're like, okay, we have stuff on the top and the bottom being multiplied here. Anything that's a whole set, you can't get rid of parts. Like I can't get rid of this x and this x. I have to get rid of this whole set if I'm going to get rid of it. I can get rid of anything that's being multiplied. If it's addition or subtraction, then I have to get rid of it as a whole set. So here we have x plus 6 and x plus 6 removed. And so what's left is an invisible 1 on top and the x minus 3 on the bottom. So, and this started off, by the way, similarly to a regular addition problem. Like if you had, sorry, my brain just paused. If you had 1/6 plus 1/6 that had caused this 2/6 I had a minute ago. See how the bottoms are the same? And when we put this together, it becomes 2/6. So the basic rules of fractions are going to apply all through this module. Normal addition means that you have to have common denominators. And once you have them alike, that stays alike in the answer. So that's what happened here. Since they already had common denominators, we just add the top parts, but this bottom part is what was in the answer until we needed to reduce it. So down here, we do the same thing. These already have common denominators. They don't need to be factored on the bottom. It's already in its simplest form. And so now if we add going across the top, we're going to combine like terms, and I did not write this down correctly. I'm going to skip that one because one of these has an X and I don't remember which one. So let's skip that one. Let's go to this one. Yeah, always double check that you write things down correctly because that's where I always messed up. Okay, so here we have the common denominator of 3a plus 5 will be on the bottom of our answer. And then here we're going to put together the negative 7a with the positive 19a, and then the negative 1 and a positive 21 are going to go together. So that's combining like terms. So we get 12a when you put the 19 minus 7, and then a positive 20, because positive 21 and negative 1 is a positive 20. And then again, just like in regular numbers, if you come up with an answer, you need to reduce it. You need to simplify it. Well, we got to factor things to see how to simplify it. So when I look at these two terms, I'm like, the biggest number they have in common is a 4. If I pull a 4 out of there, divide a 4 out, factor a 4 out, I can have 3a plus 5 left over. And on the bottom, I still have the 3a plus 5. So now I can see what was being multiplied. And like I did up here with the 2 over 2 times 3, I can see now what's being multiplied. It's 4 times 3a plus 5. And so the set that's alike, that's involved in multiplication, is the whole set of that. So that's how my answer just becomes 4. So down here, and I want to go back up here a second. So when we were doing these problems up here, especially this one that we just did, you could have looked at it as just the top part, which is 19a minus 1 plus 21 minus 7a. And back in much earlier sections, we learned how to do addition of polynomials, where you just combine the like terms. The negative 7a comes here, and the positive 21 here, and you put it together, and you get 12a plus 20. So that's the kind of thing you want to think about here for subtraction. Back in that section, when we saw a problem that looks like this, and the directions are always what's not in the parentheses there, this is a subtraction problem. And back then we learned that you could add the opposite, or what they call change, that subtraction works better if you just change the signs of the second set. In fact, we did that in long division too, when we had some long division that was, I know y'all didn't like that, but let's say we had a long division here, and whatever was out here caused us to have 3x squared minus 8, for example. And we said, hey, we got to subtract here, but instead let's just change the signs. Let's to the opposite, so we can just combine them. We can then just add them together, basically. The same thing works with subtraction of negative numbers. You can say 8 minus a negative 4, or you can change the subtraction to addition and change the sign of the second number, and you'll still get the same answer. 8 minus a negative 4 is the same as 8 plus 4, because the two negatives come together to make the plus. So the same concept continues on in this subject, where we have subtraction, and we can say, instead of subtracting this set, let's add the opposite. So let's add negative 2x minus 1. And hopefully this is refreshing your memory on what you did way back when. But then this part right here, this negative 2x minus 1, is what we brought over here originally in the way back when. And we said, okay, now let's put together negative 2x minus 1 as like terms that can be combined, and we would have 2x plus 1 in the end. So this idea that you've done previously in another module is what you're going to think about when you're doing subtraction, that it's a subtraction problem, so we turn it to addition and change the sign of the second number. And so here we have subtraction. So let's call it addition, and then change the signs of the second set. Make it everything in here the opposite. So this is going to be thought of as 2x minus 5 instead. Or like this one down here. And we're going to change it to addition, and this is going to be thought of as negative x squared plus 6x. To start with. And that's one way to do it. I actually would maybe factor, well, that's another story. Anyway, let's not go there. All right, so these have common denominators. They need to be factored, but we need to put together what's on top. If I factor the bottoms here, it's x minus 7 and x plus 3 is the factoring version of this. So we know on the bottom we have x minus 7, x plus 3. On top then we have 3x added to a negative 2x. So that's going to give me a positive 1x. And then negative 2 minus 5, which is negative 7. And then with our answer, we need to simplify it. And we can see that there is an x minus 7 on both top and bottom. So we have a 1 left on top and the x plus 3 on the bottom. Over here, the bottom's already factored. So we don't have to do anything with that part. On top, we have x squared minus x squared, because it's x squared plus a negative x squared. That actually made the x squareds cancel out. That becomes 0. So now what we have is negative 12 plus 6x, which those are not like terms. So we're just going to write it as a positive 6x minus 12. And then the bottom stays the same. And then to figure out if this can be reduced, let's factor out. I see a 6 in common. Always pull out the largest thing you can. And then on the bottom we have x minus 2. So now we can see what they had in common on top and bottom. Now you're going to do more of these problems, but you're going to get into sections where they don't already have the common denominator. So if we had, let's say we had 3x over x plus 3, and it was said minus 2 over x minus 1. Well, these sets are not the same, so what we can do is make them the same. We would say, okay, whatever this one has that this one doesn't, let's bring it over here. And whatever this one has that this one doesn't, let's bring it over here. So that what we would say is the denominator is going to be the combination of them all. It's like finding the common denominator in normal fractions, where you need to find something that's common between them. And so we want them both to have the x plus 3. Now, I didn't just do that and say, oh, well, that's just what you do, because it changes the problem when you do that. So if you're going to do that on the bottom, if I'm going to give this an x minus 1 here, I also have to give it to the top. And if I'm going to give this an x plus 3 on the bottom, I have to give it to the top also, and we're multiplying it when we do that. So this one then would become 3x times x minus 1, and we have to distribute that. So it'd be 3x squared minus 3x, and this one would be 2x plus 6. So now that it had the common denominator, we're going to combine the stuff that's on top. So I have 3x squared, and I ended up with a negative 1x, and I have a plus 6. And then that's over that common denominator that we created. Now we want to see if this can be factored. And it can't be. This top part happened to be prime. I made up the problem. It always works out that way. I don't make up good problems. But if this part could be factored on top, we would just do like we did up above and factor it, and then see if there was anything on the top and the bottom that we could eliminate that they had in common. But in this case, this would be our final answer.